Most prompting advice never meets a test that could actually kill it. It just sounds right, someone repeats it, and it becomes a rule nobody rechecks. Three practices from my own pipeline work did meet a real test, and I want to walk through what each one found because one of them came back with a warning I didn't expect. The fix most people reach for is aimed at the smaller half of the problem. Start with the simplest check, judging an AI output twice, once with each candidate answer in the first slot, once with them swapped. If the verdict flips when nothing about the content changed, the judge is reading a slot, not an answer. I ran that across 3,000 blind pair judgments in a real pipeline. Grading with the cheap model, OpenAI's smallest tier, self agreement on that swap landed between 5 and 28%, depending on the criterion. That's barely clear of the 33% chance floor a three-way win, lose, or tie verdict carries. It also just picked the same letter regardless of which candidate actually held that slot, 70 some to nearly all of the time. Swap in a bigger judge tier, same prompts, same pairs, and self agreement jumped to 71% through 88%. Model choice alone did most of the work. Here's the part that changes how I read that fix. A 2026 evaluation ran five judge models from four separate providers through a controlled 225 pair test, holding content identical while only the formatting changed. Style bias, a preference for markdown formatted answers over plain prose, measured 0.76 to 0, 92 across every single model. Position bias, the thing the swap I just showed you actually corrects, measured 0.04 or below on the same models. By my own math, that puts style bias at roughly 20 times the size of position bias, and it's the one almost nobody checks for. So, does running the position swap also clean up the bigger problem? Mostly not. The paper's own position swap runs the exact fix from slide 2, cut style bias by only about 0.12 on average. That's a side effect of correcting for order rather than a targeted fix for formatting. So that leaves most of a 0.76 to 0.92 gap standing. Swap position and stop there, and you've basically closed the bias worth zero point zero 0.04 while leaving one worth 20 times that untouched. The second practice, what I am calling a de-anchoring check on a prompt that carries one worked example. Run the prompt as written, note the pattern in the output, swap that one example for a neutral substitute, change nothing else, and rerun. If the pattern holds, it belongs to the underlying data, but if it disappears, it belonged to the example you just removed. It's a cheap, rough test rather than a full fix, and it flags a bias instead of correcting for it. That move is not published under this name anywhere, but the underlying risk is. Few shot prompting means handing the model worked examples before the real question. And one study found that permuting the order of those same examples with nothing else changed can swing accuracy from near chance to near state of the art on GPT-3 era models. A separate paper built a fuller fix for a related failure. Let's say you feed the model a content free input, read off which answer it defaults to with no real content at all, then use that default to recalibrate its predictions. That correction improved accuracy by up to 30 percentage points on some tasks. My de-anchoring check is basically the cheaper, rougher cousin of that fix, and building the fuller correction is a separate, bigger project I have not taken on. But the third practice, and it starts from a plain fact rather than a study. OpenAI's own reference for the chat completion endpoint lists reasoning effort, a setting that controls how much internal reasoning the model spends before it answers, as a flat, optional field. It names 7 allowed values: none, minimal, low, medium, high, x high, and max. Neither that reference's own reasoning effort entry nor the separate reasoning guide ties the older temperature setting to how a reasoning model behaves. In my own pipeline runs, passing any non default temperature value to one of these models just returns an error every time. That's a first hand observation on my part, and not something either document states outright. So, where does deterministic output actually come from now that the sampler is off the table? Three things stacked. In output schema, the API guarantees will match what you asked for, an explicit reasoning effort setting instead of whatever the model defaults to, and a prompt that lists every legal value instead of leaving the model to infer them. None of it costs materially more, which surprised me. The three tiers in the current model family run 0.2 to $5 per million input tokens. confirmed against the live pricing page the same day I wrote this. So here is what I would actually do with this before trusting any of it in your real work. Run the position swap this afternoon, 10 to 20 pairs, judge twice, once in each order. Divide the pairs that agree by the total and compare that rate to the chance floor for your own verdict schema. If that rate sits within about 10% or 10 points rather of chance, the judge is reading a slot rather than the content, and every verdict it has produced so far is basically noise. A rate in the 70s or higher is worth trusting enough to act on. Even then, I would treat a clean position swap score as a floor rather than a clearance, since style bias never runs through that check at all. The full write up, the paper, and the pipeline numbers are on my website, but I'm curious which of these three you've actually tested or on your own setup, and rather than just assuming it works. Thanks for watching, and I'll catch you on the next video.